Hi everyone, thanks for joining me today, straight after lunch. I hope it was good for you all. It sure was for me. So, the upcoming 40 minutes I'll be talking about DevOps and compliance and how the two can actually work together, can nicely be integrated. So, my name is Erwin Staal. I'm a software engineer and ALM consultant from the Netherlands, and I work for a company called 4.net. And as I told in the introduction, we do staff consultancy, etc. Training related to the Microsoft.NET technology stack. But there's also DevOps and stuff like that. A couple of Angular trainings. So if you want to reach out to me after today, there's my Twitter handle. You'll probably will be getting the fastest answer through Twitter. Alright, so today will be about DevOps and compliance. So let's start with DevOps first. This is a quote from Donovan Brown. He's a principal program something at Microsoft, and he came up with this definition, which we saw earlier today in the keynote. So I want to highlight two things here. One is that he's talking about value, not just software, but value. So anything a user could benefit from, that's value. So DevOps should be about all of that. And he also talks about delivering this value to our end users. So delivering this value to your Q&A environment is not enough. It has to reach your end users. So that could be a web application landing on Azure, or that could be a mobile app on their iPhone, for example. Alright, the other one from the title, compliance. What is compliance? Wikipedia states that compliancy means conforming to a rule, such as a specification, a policy, a standard, or a law. And as you all probably know, there's quite a lot of these standards and specifications, etc. There's some standards that are relevant to everyone and to the world. There's also a few that's European specific, and there's also a few that's specific for your particular country. So we have a few of our own in the Netherlands. So there's even companies having their own on top of this. So for example, I currently work for a company called KPN. KPN is the largest Dutch telecom provider in the Netherlands. And so we have our own. It's called the KPN security policy. And I had to deal with this one quite a lot recently. Most companies keep these policies and these standards for themselves. KPN didn't, so there's an app for that. There's an app for everything, right? So there's an app for that. And it's open source on GitHub. So it's freely available for all of you. It's even being used in the Netherlands, at least by other companies. Our Dutch railway company uses these standards as well. I'm not sure what they would do with a pull request. But you could at least try. Alright, to give you a few examples of the stuff that's in there. So just to give you an idea of what's out there. For example, this one, it's about the fact that we have to use HTTPS for everything we do. For all the obvious reasons, right? So another one, we have to have stuff in place to prevent CSRF. And what I like about this one, and is that it's pretty concrete, pretty precise in what you have to do. It states stuff around that you have to use tokens, and that these stuff has at least to be unique per session. In a lot of standards and policies, etc., that's not the case. They're much less concrete. So that's what I like about this one particularly. Alright, we do have a few of them which are less concrete and thereby lead to a lot of discussion. For example, this one. This one's about network segregation, and the fact that we have to make sure that especially private data cannot be reached directly from the internet, but there are layers in between, making sure we can hide this private data. So this one's less concrete, so there's always a lot of discussion around this one. There's a lot of gray areas here. Alright, another one. It's about rate limiting. We obviously have to implement some DDoS attack prevention. So that's in there as well. And another one which is pretty concrete is about password hashing. It states how you should do that. And there's another one about which algorithms you should be using to hash your password. And if you would scroll down in this document, then there's also a list of hashing algorithms you're not allowed to use anymore. So MD5 for example, is in there. You're not allowed to use that anymore. So pretty concrete list of stuff you have to do. If you look at these controls and these requirements, then they are all about security, information security, and therefore they all fall in one of these three categories. So they're either about availability, integrity, or confidentiality. So availability, to start with, is all about information should be available for authorized users. So this is about making your data, etc., available. So if you would look at what stuff that's in here, here we're talking about how do you handle a hardware failure? How do you cope with disaster recovery? How do you handle the fact that your operating system should be up to date all the time? Stuff like that. So integrity is all about the fact that data should not be modified in an unauthorized manner. So for example, we as engineers use version control, and you should use version control for everything, because then at least we know that if someone changed anything, we at least know when they did it and when that was deployed to our production environment. This is also the reason why, or one of the reasons, obviously, why we have deployment pipelines. If we're using deployment pipelines, we're at least sure that the stuff that came out of our build, the artifact, is in fact what has been released to our testing environment, and those bits are exactly the same as what has been delivered to our production environment. So that's in there as well. The last one, confidentiality, is all about preventing unauthorized disclosure of information. You could probably replace this term with privacy. It's all about preventing your data being out there, being read by someone who shouldn't. So this is probably about stuff like password length. How often should you change your password? Should you implement two-factor authentication or not? Stuff like that can be found in this one. Alright, so if you look at this stuff from a DevOps perspective, then what I often see is that people start to care about compliance and stuff like that after they sort of finished and want to go to production for the first time. Then they are going to worry about this stuff. But you should actually start worrying about this stuff, start worrying about security early in the process. Just like we did with our testing, just like we did with operations, you should obviously move this security stuff to the front. Make a shift left here. Alright, so this compliancy thing is most of the time it's about security, and this is a nice quote from Michael Hayden. He's the former director of the NSA and the CIA, and he says fundamentally, if someone wants to get in, they're getting in. You have to accept that. So if someone wants to breach you, wants to hack you, they are getting in. And the other one is nice as well. You are certainly penetrated. So those are quite bold statements, but there's a mindset shift behind all of them. So it all have been about preventing breach. So the stuff on the left here, whereas he says that you should probably spend more time on the other side, assuming breach. We should assume that you will be breached sooner or later. So the stuff on the left, we sure have to do that, but you should also care about the stuff on the right. So you should, for example, spend some time on implementing monitoring around being hacked, being penetrated, so that once you are being hacked, are being penetrated, you at least know, and you at least know what they were able to see, so that you can at least think about how do I recover from this, and how do I prevent this from happening in the future. Being able to at least know that they penetrate you is a very important step. Very important first step. All right. I read an article from Jez Humble recently. He's the author of the Continuous Delivery book. He wrote together with Dave Farley. And he said, we used to live in a world in which we cared about mean time between failure. That is, we used to care about, we used to go very slow and be very careful about what we do to prevent failure. But he says we should actually care about mean time to restore service. We should actually care about how fast can we recover from failure. In this modern world, with these very complex systems we're all building, all these very complex microservice systems we're building nowadays, you could probably state that failure is inevitable. Your systems will sooner or later fail. You will sooner or later be hacked by someone. If you haven't been hacked yet, if you haven't been penetrated, that's either because you don't know, because you just didn't see it, or the information you're having isn't of much value to anyone, so they're not trying to attack you. So if you have information that's valuable, you will probably be hacked anyway. Alright, people often think that these two things, being very, very fast and being all about quality, cannot be done at the same time. But there's been a report last year, the State of DevOps report, and what you see here is that companies who are very good at stuff like continuous delivery, they go to production way more than companies who aren't that good at it. They're also very much more capable of bringing new ideas to production quickly, and they actually make less mistakes while doing so. So they're going to production way more often than companies who aren't very good at continuous delivery. And while doing that, they are making much fewer mistakes than the companies who are not very good at it. And once they, and if they do make a mistake, they also are able to recover from that much faster than companies who are slow, who are very careful about what they do. Alright. Especially in larger companies, there's a problem, however. And I ran into this problem at KPN and at a few other companies. Some of the controls we've been talking about are implemented using a change advisory board. That's a group of people who get to have a vote about the change you're about to release to your production environment. And if you are lucky, this board comes together once a week to decide about all the change requests that have been added in this week. And if you're lucky, they approve your change on the first run, and you'll be allowed to go to production. So there's no going to production 10 times a day with something like a change advisory board in place. So we had to come up with a solution to make sure we were allowed to do this, and to make sure we can really go by speed is the new security. So what we did is that we actually started talking to them, and they turned out to be human, and they turned out to have the same goal as we did, which is delivering value to our end users, high quality value to our end users. So these are 6 of the things we came up with, stuff that we have to have in place for them to allow us to go to production release whenever the hell we want. So the first one is probably the most important one, in the upper left corner. It's about making sure that every change you do is what we call a low-load change. So there's no impact for your users with this change, and of very less impact at least, and there's no risk involved in this change. So for some of us it's pretty hard to achieve this, especially stuff like database changes, for example. Sometimes hard to do, but it means that we need to be able to do 0 downtime deployments. So we can actually now, and we even release our software Friday afternoon 5 p.m. It doesn't matter anymore. All right, the other one. One of the primary reasons this change advisory board is there anyway is because of this 4 eyes principle. Someone else should be looking at the change you're about to make and see what the impact of this change is. So we came up with a solution to be able to cover that one as well. I will show you in a bit. There's continuous testing. If you want to go to production a couple of times a day, then obviously you cannot do regression testing by hand anymore. So you have to automate all your testing. But you can also automate some of these compliancy requirements. We have tests, UI tests in there, which test our rate limiting, for example. They can all be in there as well. We talked a bit about deployment automation already. You should obviously automate every step you have to take here as well, so that you can prevent manual error here. And also make sure that every change you do has been released to a Q&A environment before you actually push that one to production, to make sure that you can catch mistakes and bugs early up in the process. Alright, another one, configuration management. If you want to be able to automate everything, and you should, that's the only way to prevent human errors, then you need to make sure that you put all of this stuff in version control, so that we at least know who changed what, and that we can use this later on in our processes to make sure that they are always reliable and repeatable. So one last thing, register change. We used to have to register every change we did in a global system, so that this would be transparent for everyone and everyone could find this change in case there was something wrong. We still have to do this, but we were lucky enough to be able to automate this. So every time we do a release towards production now, this change will automatically be registered in a tool we use, so that if anything goes wrong and a client calls us, we at least know, the people on the phone at least know that a change was going out, and it might be related. Alright, some other interesting point, if you look at implementing these controls, then what you used to see is that just a few of these controls could actually be implemented by developers. Developers should obviously not use MD5 anymore for password hashing, but most of these controls were actually being implemented by the operations people. And in the old world, that meant a lot of work if you're still running virtual machines, for example. But nowadays, we can leverage the cloud. And what you see here is that the stuff that our operations people have to do has become very minimal, because a lot of these controls, implementing a lot of these controls, is actually handled by your cloud provider these days. So stuff like preventing someone walking into your data center and actually stealing a server or whatever, you don't have to care about that anymore. And there's obviously a lot of other examples that they can handle for you now. This is a nice graph that shows somewhere about the same stuff. So implementing these compliancy rules, then you can really benefit from using cloud instead of doing everything on your own. Alright, enough for the talking. Let's go to a few demos to see how we are doing stuff today, but also about how you could be doing stuff and how we would like to be doing stuff in the future. So not all of the stuff I'm going to show you here today is stuff we are doing today, but quite a lot of it is. Alright, can everyone read this? Could probably enlarge it a bit. For those who haven't used this product, this is Microsoft's Azure DevOps, formerly known as Team Foundation Server. And it's the tool we use for version control and the tool we use for our builds and our releases. And you are currently looking at a pull request. So I've made a change to our code. And I've been asking a couple of my colleagues to review this change, and this is what that looks like. And the nice thing is that we can do a few interesting things here from this pull request already. As you can see up in this corner over here, it states that there are a few policies, and one of them is that at least one of my colleagues needs to have to review this change. So I can't put this change through to production without at least having one of my colleagues view what I've been doing here. And since we put everything we have in version control, so that's database changes, there's infrastructure changes, there's configuration, and there's code. Everything we do which ends up on production is being reviewed by at least one colleague. So that's awesome. 4 ICE principles being covered here. The other one in the middle is it says build succeeded. While I submitted this pull request, a build was being run on the background. In this build, my application is obviously being compiled, and a pretty comprehensive set of unit tests has already run. So even by the time my colleagues get to this pull request and get to look at it, I'm pretty sure and pretty confident about this change already before they even look at it. And if even one of these tests would fail, then I wouldn't be allowed to push this on to production, and I would have to fix that first. Alright, another interesting point here, down here. You see I implemented an MD5 crypto blah 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 provider, which I shouldn't, obviously, we talked about it. And I have a tool implemented here, and this tool is called Sonar Cloud. There's also Sonar Cube if you're on premises. And what this tool is doing, it's running a static code analysis on my change, obviously. And it will add comments to my pull request. It will automatically add these comments to my pull request if it found anything that I shouldn't be doing. So this one is about security. This one's about a vulnerability. But it will also scan my code for things like duplications and unit tests, code coverage, for example. But this one is really nice. It told me that I implemented something which I shouldn't, and it's I could even click on these links to get a bit more detail, and there I could read about why I shouldn't do this, and I can also read about alternatives to implement this thing. So that's really cool. That's all being automated here, and so that's using a third-party tool in this process. If there's not a third-party tool you could use, then you can always script something of your own. So I did. One thing you see down here is that it states that my PR title is incorrect. My pull request title is incorrect. That's a check I built myself. And what I do here is that once this pull request is being created, a webhook is being fired to a Azure serverless function, and that will check my title. So what I did here, we are in Azure DevOps with version control, but we aren't in Azure DevOps if it's about work items. So we use Jira for that. And since there's no direct coupling in our company between Jira and this Azure DevOps, I cannot make this direct coupling between a work item and the change I'm actually doing in code. So what I've done here is I've created a function which will check the title of my pull request, and it has to start with these quotes, and between them there must be the work item number from Jira. So this is being fired now, and sometimes it takes a bit long and I have to refresh the page. But you should probably see that now it states that this one is ready for review, and I'm done here. So even if in the beginning of this process, there's quite a few things you can do to check your changes, whether they're about security or compliancy, stuff like that. Alright, let's move on to something else. Another thing I'm running during my build is a scan by white source bold. And what this is doing this scan will go through all my dependencies. Since this is a .NET application, these dependencies come from NuGet, and this scan will go through all of them and see if there are any vulnerabilities in these third-party open source dependencies I'm using. And there's quite a few of them in this code base. I've been using this demo application for quite a while now, and I haven't updated it. So there's pretty much detail about what's going wrong and if they fixed it in some version. So that's nice. And another thing this tool can do for you is the stuff on the bottom here. It will show you a list of all the licenses that come with these third-party dependencies. So there are a few licenses which you shouldn't be using in the open source world, because if you would implement a dependency which uses this license, then you would need to open source your stuff as well. And we obviously do not want that within our company. So this will give you a nice overview of the licenses you're using and if that's okay or not. Alright, let's move on. This is a deployment pipeline in Azure DevOps, and we're not going through all of this stuff, but I want to tell you a little bit about a few things in terms of compliance, etc. And the first one is that you see over here that it says create or update my website or create or update my database. So what I'm doing here is that from my deployment pipeline, I will create my resources. I will create my database, and I will create my web app that I need within Azure to deploy my application to. So that's nice, because the definition of these resources is in version control, is in JSON format, and if anyone would change those, I would be able to see that in version control. And the one below there, that one is pretty interesting as well. It's about migrating your database. So our database changes are in version control as well, and they are being applied to our databases during deployment of the application. Most of the time we migrate our database just before we actually deploy our application. And that's great because it's all being automated now. So by the time it reaches production, we at least know it has been run on our Q&A environment as well. And all of the logging these migration produces, that's all being stored in this release. So I can always go back to this and see what happened, who made that change, why did he make that change, stuff like that. Alright, by the end of this deployment pipeline, this application will be deployed to production, will be deployed to Azure in my case. And there's a few interesting things we can do up there as well. So first of all, let's go to this security dashboard. What you actually see here is it will tell you something about how compliant you are against a couple of the regulation standards. We'll go into that later. It will show you something about your security hygiene. We will see a bit more about that in a bit. First of all, let's move to this compliancy dashboard here. And this is pretty awesome, because what they did is they implemented a few of the well-known standards over here, and they are checking your resources, so stuff like databases, web applications, firewalls, etc., etc. They are checking those resources all the time, and they nicely give you a list of stuff you have implemented, but also about stuff you haven't implemented regarding these standards. So, for example, this one over here states that I should add another owner to my subscription, because currently I'm the only owner here, and that's not a healthy situation, obviously. So it's not just about the technical stuff; it's also about stuff like this. And if we were to go down a bit, we could go to the cryptography one, and what we would see over here is the second blue one. states that my web application shouldn't be accessible over HTTPS. We saw that one in the KPN security policy, and that one is nicely being checked here by Azure. I could go over here, click it, and it would in the bottom over here. Oh, that didn't work too well. Yep. Alright, so I could click on it, and in the bottom it will show which of my resources aren't compliant. So you don't have to search for them yourself. You can just click through and they will show you that. And if I were to click on one of these web applications, I would be taken straight to the page within that web application where I could fix this vulnerability. So if I were to click one of these links now, I would be taken to the page where I would be able to enable SSL, TLS, etc. Alright, so that's all pretty awesome from that perspective. There's another nice one over here in Azure. And the other one is about policies. Because what I've just shown you is built into Azure, but you can obviously also add your own policies because they're not will not be complete for every application out there. So, for example, I've created a policy over here, which is called allow locations. And if we were to go there and I would show the definition, then I can explain what's actually happening over here. Yeah, that's readable, right? Okay. So I added this policy, and as you can see, it is stating that if the location on one of the resources isn't in a specified list, then the creation of this resource will be blocked. So the result of this is that if I'm trying to create a resource, being in a web application, being in a database, doesn't really matter, and I'm trying to deploy this outside of the Netherlands, that's what I stated here. If I deploy this resource outside of the Netherlands, then I wouldn't be allowed to deploy this resource. So that's a very nice and effective way of keeping your resources within one Azure region, instead of having it spread all over the world in case you do not want to do that. Alright, so that's a nice one, but that's only preventing new stuff. What you can do as well here with a policy is, for example, the one over here. This one is for enabling threat detection on your SQL servers within Azure. And as you can see, there's a deploy if not exists effect over here. And what this will basically do is, if you would now try to create a new database and you wouldn't enable threat detection at the point you created it, this will enable threat detection on this resource. So this enables you to make sure that everyone who ever create a resource will be forced to use something you want them to do. They will not be able to create this resource without this threat protection being enabled. Alright. So, another thing you can do over here is you can even create a remediation task for the resources that aren't compliant with this policy just yet. So, if you were to create a new policy, there could be resources that aren't compliant, and if you were to implement one of these deploy if not exists stuff, then you could go over here, see the resources that aren't compliant with this policy, and just say remediate, and it will fix these resources for you. So you can have a nice way to make sure existing resources are being compliant as well. But we should obviously try to prevent people from creating resources they shouldn't anyway, and help our teams to create resources which are compliant by default. So what you can do here in Azure is you can use blueprints. And for those who are familiar with Azure and those who are familiar with ARM templates, blueprints go a bit further than just ARM templates. with Blueprint you can specify which resources have to be created and which user accounts have to be created and which policies have to be enabled for those resources. So if I would click into that, then this is the UK official networking blueprint. So the UK government has compliance rules as well, obviously, and this is an implementation of their compliance rules. And so what they actually do when they're launching a new application for the UK government, they pick this blueprint and deploy this to Azure, and it will give their teams a nice environment from the start with it, which is compliant. So if I would go to my resource groups over here, oh, there's quite a lot of them. Here it is. Alright, so what you can do now, as an architect, you can create these blueprints. You can provide these to your teams, and if one of your teams will be implementing a new application, will be releasing a new application to production, they can just pick this blueprint, have it deployed to Azure, and something like this could be the outcome. So here, for example, a few network specific stuff has been released to Azure, and their teams can start implementing this stuff right away. And you know from the beginning that you are compliant with the rules of your company when you would use blueprints like this. So that's a nice way for architects to help your teams to be compliant from the start and not have every team figure this compliancy stuff out on their own. Alright, with that I am done with my demos. So going back to my slides here. Yes. That was what I wanted to talk to you about today. Are there any questions?